Okay. Bismillahirrahmanirrahim. Inshallah, we will do some problems. After that, we will come to that RLC circuit. So we will continue our discussion on RL circuit because you have studied in the last lecture what are all the response. This response, do you remember? I think so, right? This one you remember? This equation?
Yes, yes,
This
doctor,
is the yes, it is with the source. If you connect a source, okay, that is the response. Inshallah, we will see it, and we will see the question first. Question number 1. So we have a resistor and an inductor, and we have a voltage source delta of t. You know what delta of t is? An impulse function, and you want to find the current. What is the equation for the current actually? So I am going to use the Laplace transform approach here. Okay, what will be the current? Okay, so you are giving an impulse input to this. This is your impulse input, and you know the impulse input is having a Laplace transform. What is the Laplace transform of impulse function?
I have no idea, sir.
Excuse me. The Laplace transform of impulse function is 1. The Laplace transform of impulse function. Okay, you have to remember this thing. Delta of t is having the Laplace transform 1, and u of t is the unit step. It is having Laplace transform 1 over s. And if you have a ramp function u of t, then it become 1 over s square. You see, s is getting, you are adding more s. Okay, so this you have to remember. So I am convert the network into Laplace domain. So in Laplace domain, this voltage source become just 1. Okay, and R, you know, it's R itself, and L become S into L.
SL.
This we have studied.
Excuse me, doctor.
Now we will write the yes.
T multiply by step function Laplace transform 1 by s.
1 by s square. Sorry, 1 by s square. Sorry.
Yes, yes, doctor. Thank you.
Doctor,
I will give you
why
the general formula.
coil
Yeah.
turn into resistance?
Sorry.
Why coil turn resistance in Laplace transform?
Oh, no, it's not resistance. It's my mistake, actually. Thank you for it. Okay, it's not resistance. I will give you the general formula. Laplace transform of t raised to n into u of t is n factorial divided by s power n plus 1. This is the rule, actually. Okay, then you can calculate for anything, for any n. So this is a general rule anyway. So we are going to write the Kirchhoff. We want to find the current I of S now. So if you want to find the current I of S, what will be the current I of S? First of all, we have to write the Kirchhoff law in Laplace domain. It is minus 1, right? The current is flowing like this. So plus I of S into R, right? The current is flowing like this, plus I of S into L. Am I correct? This is equal to 0.
Yes, doctor.
So
Yes,
by
doctor.
from this equation, you will get I of S is equal to what will be? It will be 1 over L into S plus R over L. This will be, if you solve this equation for I of S, you will get it. Okay, you just solve it for I of S. Now I will remind you some rules in the Laplace transform. Some rules, okay, some golden rules you have to remember. It will be helpful for you in automatic control. Okay, definitely it will be helpful for you. Suppose you have a signal x of t which is having a Laplace transform of x of s. Then if you multiply the same signal with e power minus at into x of t, then it will be the Laplace transform
We have delay.
x, yes, this become s plus a. If you multiply with e power at into x of t, then it will become
Minus a.
yes. This is a very important rule. Okay, so you can see here, according to this rule, we can see here I of s is nothing but some constant, which is a constant 1 over L multiplied with s plus r over L. Now you know that 1 over s is having the inverse. We want to find the I of t. So this constant, it will not change, 1 over L. But you know that 1 over s is having, what is the Laplace transform of 1 over s? Sorry, Laplace
It is
inverse
constant.
Laplace transform.
It is constant.
What is the inverse Laplace transform? This is Laplace transform. U of t is having Laplace transform. U of t is having Laplace transform 1 over s. Yes, it's the unit step. If you just go backwards, it is unit step.
Doctor, we have to do a partial fraction here, I think.
No. There is no requirement for partial fraction. Okay, because there is only one. There is no s square or s cube. The degree is 1, so it's simple. Okay. Now, when do you get this? This is in the form. You can see here. This is in the form s plus a.
Yes, doctor. It will
What
be
is
E minus R by L.
yes? And what is a here? What is a is r over L, right? Am I correct?
Yes,
This is in the
right.
form. So this become e power minus a into t, right? Minus a into t. And what is a? I will go substitute a by r over L. So this is the answer. This is the current. Got it? So that's why I
Excuse me,
told you
doctor.
to just refer. Yes.
From where you bring exponential minus R by LT?
You see this rule? That's I'm showing now. This rule. See this rule. This is the rule in Laplace transform. Okay. If you have s plus a in frequency domain, then you have exponential term in time domain. That is a rule in Laplace transform. You can prove it mathematically. Okay.
Okay, sir.
So I will just explain to you. You know that 1 over s is coming from u of t. Do you agree with me? 1 over
Yes,
s is
sir.
coming from.
Yes, doctor.
Yes,
Then
doctor.
1 over s plus a. Actually, if you take the inverse, then it become. You have already u of t, but you have to multiply it with e power minus a into t. In our case, a is equal to r over L. That's it. So you will get the answer. Our answer is I is equal to 1 over L e power minus t over L by r. I can write like this into u of t. Is it okay? R over L means 1 over L by r. This is equal to
Yes.
1 over L into e power minus
doctor.
t over minus t over tau into u of t. This is nothing but the initial value is 1 over L and it is exponentially decaying. You understood?
Yes,
So our
doctor.
circuit was like this. So you can see here, you are giving an impulse voltage. Since you are giving an impulse voltage at t equal to, I will just consider the time domain analysis. At t equal to 0 minus, what was the current? IL of 0 minus. What is the current here? I of t is nothing but I.
IT.
Zero.
Right? And what will be IL of 0 plus?
Zero.
Also zero.
Are you sure? I am giving an impulse voltage.
Not
Be very
zero.
careful.
It is greater than 0 minus.
Yes, that means it is nothing but you have to use the formula 1 by L integral minus infinity to t, right? V of
Yes.
t that you are giving. So you are giving an impulse.
We'll give you one.
Delta of t, that means 1 by L, this t equal to 0 plus you have to substitute. This become 1 by L, 1 over L, right?
Yes.
Yes.
Yes, doctor.
Then-
0 minus it will be 0.
Yes, at 0 minus it will be 0, and at 0 plus it will become 1 over L. Okay, don't forget this concept. It is special case only for impulse. If you give impulse voltage to inductor, it will change like this. If you are giving unit impulse, it become 1 over L. Similarly, if you have an RC network, if you give impulse current, then it will become 1 over C. Okay, don't forget it. Okay.
Okay.
So this is a special case only for impulse. Other cases you don't need to worry about it. Because impulse means a voltage you are giving only at time t equal to 0, and amplitude goes to infinity, and area become 1. That's why. And you can see what will happen. Your current through the initial current means your I all of 0 plus. That means your I of 0 plus become 1 over L. And you know that this is a RL network. In an RL network, the time constant is L over R. Is it okay? So the response become, it will start with initial value 1 over L, and it become e power minus t over tau, and tau is equal to L over R. So both are same. You can see here, this one and this one is same. So whatever you are getting using Laplace transform and whatever you are getting using time domain analysis, both are same. Okay? This is clear to you. This problem is clear to you.
Yes.
Doctor,
Yes.
it's going to 0 because of the impulse, right?
It is because of the impulse. Because
okay.
after you give, when you give the impulse at time t equal to 0, what will happen? The voltage become for t greater than 0 plus or t equal to 0 plus. What will be the voltage?
0.
Voltage equal to 0 means this becomes short circuit, right? At the
Right.
side, at this side, this becomes short circuit. So if it becomes short circuit, it becomes a source free RL network. We have already studied source free RL network. What will be the situation?
Yes.
Initial value is 1 over L, and it's same like that. Okay.
Okay.
So now next the question number 2. This is 2 ohm resistance and a 2 ohm resistance. It's 20 times U of t, and 1 ohm and 1 farad capacitor. That's it. Okay. And the current through the capacitor is IC of t. Okay. And that's it. Okay, we have to find this VC of 0 minus, VC of 0 minus, and second you have to find VC of infinity, and third you have to find what is the time constant of this circuit. You are giving something which is known as a step function here. This is a step function. Then what will be at t equal to 0 minus, at
It is
t
0.
equal to 0, yeah, it was 0. U of t will be equal to 0. If u of t is equal to 0, what will be the initial voltage of the capacitor?
It is 0.
Vc of 0 minus become, here is no voltage, means you are giving an
Yeah.
input of 0, that it is 0 volt, nothing. Capacitor was initially 0 volt. Okay. Now what will happen at infinity? At infinity, you are giving 20 volt. You can see here, you are giving 20 volt, and there is no current here because capacitor is fully charged, right? IC will be 0, right?
Right.
And you are giving here 20 volt, you can say. So this is 2. So what will be the voltage across the capacitor? Just voltage division. There is no voltage drop here. This is 0 volt. So all the voltage will be dropped across the capacitor. It will be how much?
10 volts.
Yes, 20 by 4 into. That's it. Now what is the time constant? For finding the time constant, what you have to do, you have to short circuit.
So
You have to short circuit. Yes, you have to short circuit the voltage source. This is 2, this is 2, this is 1. So C. So what will be the time constant? R equivalent into. What is R
Two
equivalent?
current
It is very easy for you.
and
2.
Yes, yes. So it will be
2 and
2 into 1, right? Yes. So it
Yes.
will be 2 seconds. That's the time constant, 2 seconds. Now we will find the fourth one. What is the equation for the current and how it will look like? Okay. What is the equation for the voltage across the capacitor? We will find what is the equation for the voltage across the capacitor. Vc of t. So Vc of t is the question. Vc of t is having a form. I told you, if there is a source, the equation will be Vc of infinity plus Vc of 0 minus Vc of infinity. Do you remember? Into e power minus t over tau. This equation I have already told in the last class. You can see
yes.
for inductor, the equation, it's like this. For the capacitor, instead of this, it will become just only the changes, it's the voltage. Equation, the structure of the equation is same for inductor and capacitor. For inductor, it will be the current, and for the capacitor, it is the voltage. So we are finding the voltage of
Doctor, we can
the capacitor. How the, sorry? What is your question? I
this
didn't get
equation
you.
came. This equation came from the step
It,
source, because after V infinity time will
yes,
become
yes, yes.
infinity.
It's
We
a
will have
constant source.
20.5.
It is a constant source, step source, but the amplitude will
Yes,
change.
yes.
Maybe 20 volt. Step source means it's a DC source, right? Step means what? It is a DC.
Yes, yes.
Here it's a DC, but DC will start. Your switch will close only at t equal to 0. That's it. You understand? This is step. Don't forget this. This is your step. Step means it's DC, but your switch will closed at time t equal to 0. That's it. So what is Vc of infinity? Vc of infinity is 10 volt plus what is Vc of 0? It's 0 volt minus Vc of infinity is 10 volt into e power minus t over tau. Okay, so you are getting this equation. Okay, this is the equation. So I am going to rewrite it. Okay, okay, write it again. This is equal to, you can take, yes, 10 into 1 minus e power minus t by 2. Is okay? Yes. So
Yes.
Vc of t is equal to 10 into 1 minus e power minus t by 2. So I am going to write this, how it will be charging. You can see as t tends to infinity, what will be the final value? The final value, we know it's nothing but 10 volt, right?
Yes.
So it will charge maximum to 10 volt. So it is going to maximum of 10 volt. And you know this is the equation for 1. If I plot 1, this is the equation. And e power minus t over 2 is nothing but this equation. And I'm subtracting. So please be careful about this thing. So 1 minus, this is not 1, we can say 10 into 1 is nothing but 10 volt. And this is nothing but 10 into e power minus t over 2. So what will be the equation? At time t equal to 0, what will be the value? 10 minus 10 into e power
10.
minus 0.
0.
It will be 0. So the value will be 0. It will start from 0. Then you can see this value is and this is constant. Constant minus decreasing value means the value will be increasing or decreasing? Constant minus decreasing. This is decreasing. This guy is decreasing.
I think
Constant
increasing.
minus decrease. It will be increasing because one side is decreasing means other side will be increasing. So the capacitor will be charging like this. This is the equation for charging the capacitor, and the capacitor around 5 times constant. That means in this case time constant is 2 seconds. So 5 into 2, 10 seconds. You can say after 10 seconds the capacitor almost charged to 10 volt.
Fully charged.
You understood? Yes. And you know at time t equal to time constant tau, that means 2 seconds, the capacitor will charge to how many volt? 60, how much? It was 63.8, I think.
3.8.
63.8 means that much percentage means 6.38 volt here. Okay, I have made a mistake here in row. So it will become 6.38 volt here. This is the time t equal to tau. I hope it is clear to you. This problem is clear to you, right?
Yes.
That's okay.
Then you can see how much change will be there in the current through the capacitor. Next, IC of T. What will be the current through the capacitor? This is the voltage across the. We have already seen the voltage.
T by dt.
C in yes by dt. So if you differentiate the above equation, you will get e power 5 into e power minus t over 2. Okay, if you just differentiate the above equation, voltage. Okay, so it become the first term actually constant. Yes, then it's become, you know, that it's very easy. That means the current through the capacitor was initially 5 ampere and it is decaying like this and it is going to 0. So when this guy becomes 0, the voltage across the capacitor will how much?
Maximum.
It will go to 10 volt as we have explained. This will go to 10 volt. You understood? So when the voltage reaches 10 volt, current becomes 0. That means the capacitor is fully charged. It's clear? This is how the capacitor is charging. Yes, after fully charging, there is no current. Current becomes 0. That means it will behave as an open circuit. You understood? So this is how the capacitor is charging. I hope this is clear to you, right?
Yes.
Yes. Yes. Now we will see. We will see another problem. I am skipping some problems due to the time limitation. Now we will see something response, different types of response for the capacitors. Let's say this is question number 2. Determine the nature of response. Now you have a clear picture, I think, in your mind how the capacitor is charging. The voltage will be increasing in an exponential way and the current will be decreasing in an exponential way. You understood?
Yes.
Yes.
Don't forget this concept. Okay, this is very fundamental concept. So now we are going to find the response of different circuit. Let us assume that we have a voltage source V and a switch which is closing at time t equal to 0, and this is your R. What will be the current? That's my question. I of t. Is it charging, discharging, anything like that? Is it a constant? Because this is a constant.
Constant.
What will be the equation for current? This is time t
V
equal to
over
0. Current will be constant. Yes, V over R. There is no time here. There is no equation for time here. You cannot see any factor of time. So this is time equation. It's a constant. This is the beauty of the capacitor. So capacitor is having immediately, it will not think anything. Capacitor and inductor,
Step.
it will not respond quickly. It will take some time. But resistor will not hesitate, okay, to respond quickly. It will respond very quickly. There is no issue for the resistance. I hope it is clear to you, right? Now, second one, we have a same kind of circuit. The switch is closing at time t equal to 0, and there is a resistor and an inductor. We have seen just now this circuit, V, and this is, okay. So how the current will be looking like? I have told you.
Increasing.
It is
Decreasing.
Increasing.
Current,
exponentially.
the current will be, yes, the current will be increasing exponentially. This is the beauty. You have to just see the circuit. As t tends to infinity, the inductor become, what will happen to the inductor?
Short.
The inductor become,
Will be
yes,
short.
inductor become short circuit. That means your current will go high. That's the mean. That is the meaning, right? So it is increasing.
Yes.
Yes.
Understood? So it is having an exponential behavior. All these first order circuits are having exponential behavior. All are, this is first order circuit, okay? First order. That's why, because there's only one inductor. This is zero order circuit, okay? There is no order. This is zero order. There is no energy storing element. Zero order circuit. The order of the differential equation which is governing this circuit is zero, because there is no differential term. But here there is an inductor, so there is a differential term. If there is a differential term, one differential term means it's first order differential equation, means it is having exponential. So first order and exponential, both are same. I hope it is clear to you. First order means exponential response. Understood? The exponential response may be increasing or decreasing according to your, so the current is nothing but, what will be the maximum current? It is V over R.
V by R.
And what is, yes, what is the time constant? Tau is equal to L over R. I hope it is clear to you.
Yes.
Yes. Okay. Now we will see another, the same thing with the voltage source, and at time t equal to 0, your switch is closing here. So what will be the current through the capacitor? I told you just now.
It is decreasing
The
exponentially.
capacity, yes, as t tends to infinity, what will happen to your capacitor? Capacitor become open circuit.
circuit.
Open circuit means current becomes 0. So current
It
is
will
going to
start
0.
from V over R,
So
right?
if current is going to 0, yes, it will start from V over R, because at t equal to 0 plus, you know that capacitor is short circuit, so current will be V over R, right? So it is going down like this. And the time constant for this is, time constant is actually determining the speed of the response. So it is RC. If you have more time constant, means it will take more time. If you have very small time constant, means its response will be very fast. That's the meaning. Okay, so it is giving you an idea of how fast your circuit is responding. Time constant is giving you an idea about how fast your circuit is responding. I hope it is clear to you, right? Okay.
Yes.
The
That's
next
okay.
one, fourth one, that we haven't studied yet, inshallah we will study, inshallah. So at t equal to
RLC.
0 plus, yes, it's an RLC circuit. I will talk about RLC circuit now. This is L, and there is a capacitor. Okay, I will draw it in a different way, that's better. You have an L and a capacitor. Now everything is in series, you can see. What will be the response of this guy? Its response is something so simple. It will show different types of response according to the value of R, L, and C. But generally we can say the response will be, what will be the response? How this guy will
It will
behave?
be exponential.
Decrease exponentially.
I will tell you how, what will be the order of the differential equation. What is the order of the circuit?
The second order.
2.
second. So two energy storing elements. Two energy storing elements. Okay. Now, if there are two energy storing elements, if you connect two tank, you know water tank.
Yes.
Yes.
If you have two tanks, I will tell you just if you have a and you have a tank with nothing, maybe less water like this. If you have a valve like this, if you open the valve, what will happen?
It will be turn the first one to another one.
Yes, it will transfer the energy here, right? It will transfer the energy here. Sometimes it will become equalized. But when you, the moment when you open and close the valve, open or close, whatever, what will happen? The water will having some waves. Do you agree with me? The water will have
Yes.
some waves, right? That is the transience. But after some times, it will go to a steady, yeah, it will become a stable state. And finally, the water may be increasing or decreasing and it will finally equalize. You understood?
Yes.
If you have a very small valve, that means very narrow like this, then water flow will be very smooth, right?
Yes.
Am I correct?
Yes.
But even though if you have a very small valve, you have a big tank here. Suppose this is a very big tank. Then the pressure exerted by the tank 1 will be more, right? This is tank 2. So the pressure exerted by tank 1 will be more sometimes if you have more water here in the tank. You understood?
Yes.
So you can consider the first tank as an L, the second tank as C. So based on the tank size, based on the L, C and R, the response will change. If you have a very thin pipe like this, very thin, then the water flow will be very small, right? Very less. So
Yes.
you cannot, if it is very small or very less, you cannot expect much waves. You cannot expect much waves in the tanks. Do you agree with me in this concept, in this regard?
Yes.
If it's very, very small. But if you have a very large pipe, the moment you open the pipe, a large volume of water will flow from one tank to another tank. Then the waves will be more, right?
Right.
Yes. So it will depend upon the size of the tank, how much you are, what is the size of this? This you can consider as the resistance. If you have a big opening, the resistance is very small. If you have a very small opening, you have more resistance. It is more resistive. So based on the different values of L and C, L, C and R, you will get different types of response. Inshallah, we will see in detail. But in general, you can see that at time t equal to 0, what will happen here? At time t equal to 0, inductor become, at time t equal to 0 become,
Short
yes,
circuit.
0 plus, inductor becomes short circuit, and capacitor become, inductor
Short
become
or
open
open,
circuit,
doctor?
open circuit, and the capacitor become
Yes.
short circuit, right?
Yes.
So at time t equal to 0 plus, you will see something which is very interesting. The current will be, there is an open circuit here, this is a short circuit here, and there is a resistor here. This is the situation at time t equal to 0. So what will be the current at this time?
Zero.
I of t. I of
T
t
by
equal to
R?
0.
Oh, no, 0.
I have to, yeah, there is an open circuit. So current will be 0 now. You can say the current will start from 0. After that, inductor will, what is the response of the capacitor? You know, the capacitor is having a response. The current will slowly decrease, right?
Okay.
And what is
Yes.
the characteristics of inductor? Opposite. For the inductor,
Short will
the current will
increase.
slowly increase. Both are having different characteristics. That means both will fight each other. You understood? Both are having different characteristics. So both will fight each other. You can see here that inductor will transfer its energy to the capacitor, or capacitor is short circuit now. Due to this short circuit, the capacitor will try to charge during this process. This is short circuit and this is open circuit. As time greater than 0 plus, that means as time moves on, what will happen? The capacitor current will start decreasing and the inductor current will start increasing. So what will happen here? So who is charging now? Who is having more energy now? Who is losing energy? Yes, inductor is having current. Actually, this is the current response. So inductor is having the energy, increasing energy, and it is taken from the source. So the inductor will build the magnetic field. As inductor build the magnetic field, the capacitor will oppose it because the capacitor current is decreasing. You understood? The capacitor current is decreasing.
Yes.
Inductor current is increasing. So the capacitor current is decreasing. So what will happen is that both will transfer the energy each other. I will explain this first of all, I will give you a good idea without the resistance. Then you will understand. Let us assume that you have a circuit like this, and you have a capacitor and an inductor. Okay. Now this is R, and you have something like this. At time t equal to 0, you are closing the switch. Then what will happen for time t greater than 0? What will be the situation?
The inductor
You
will
are
charge.
charging the capacitor. Yes, at first, what will be the voltage across the capacitor? At t, voltage
It
across
will
the
be
capacitor at
BV.
0 minus, it will be V, right? Am I correct?
Yes.
Now
yes.
at t equal to, yes, so you have the capacitor having a voltage of V, and the inductor is having something like this. And at t equal to t greater than 0, this is going to the ground. So this is going to the ground. Okay.
Doctor,
Now this, yes,
at t greater than 0, you mean at t 0 plus?
t greater than
Or
0 means above 0. That means 0 plus and any value greater than 0.
okay.
Okay. Now at t equal to 0, what will be the capacitor? What will be the current now? What was the current? Inductor current now. What is the inductor current? IL of 0 minus.
V by R.
How it will become VI
It
by
should be
R? The
0.
capacitor has already charged.
It will be
0,
C dt.
0.
It is 0. At t
Because
equal
the
to 0
capacitor-
minus, yeah, capacitor is already charged completely. At 0 minus, the capacitor was charged to V volt. When capacitor charged to V volt, full voltage, then the current becomes 0. I told you. Capacitor charging is like this.
yes.
Then the current through the capacitor is like this. This is IC of t and this is VC of t. You remember? So when the capacitor charged to maximum of V, the current become IC of t become 0.
0.
That means our I of t will be the same current, actually you can say that will be current 0. So what will be IL of 0 plus? It will be
0.
0 ampere. Yes, 0 ampere. That means who is having full of energy now?
Capacitor.
Capacitor.
Yes, inductor has no energy and the capacitor is having full of energy. Okay, that means the capacitor is having electric field like this. It is having electric field like this. Okay, that means it is from positive to negative. This is the direction of the electric field. Now what will happen? The capacitor will not stand like this. It is because it has seen another path. So the capacitor will start current. It will act like a source and the current will flow like this. Is it okay?
Yeah.
Yes.
Yes.
Now I am going to draw. Please listen very carefully. This is an inductor and a capacitor in parallel. You can say both are parallel. Can I say this is parallel? Or just a circuit with inductor and capacitor, series. Anyways, this is series, just series. Okay, I cannot say parallel. There is no other thing. Okay, so see. Okay, that's it. Now you have lot of energy here. Let's say this full of energy and the voltage is V, and this is capacitor is C. This, what is the energy here now? EC of 0 plus, what will be the energy? Half CV square.
V square.
Yes. Now what will, this is V of 0 plus C square. That means this is nothing but your V. Okay, V same as V square. Now what will happen? Please tell me what will happen now. The capacitor will act like a source. Capacitor will act like a source. So it will go, it will create current. It is yes, in an opposite direction.
Is it charged
Yes,
coil?
it will yeah, it will magnetize the coil, not charging, magnetize. Okay, so what will happen? The magnetic field around the coil will increase, right? Previously there was no energy here, the energy was 0 joules, and here full of energy. So now this guy is transferring some energy. For example, this has 10 joules and it has 0 joules. What will happen? It will start transferring the energy. Then this become 1 joules and this become
9.
9 joules. Do you agree with me? Yes. So it become 1 joules and 9 joules. So what will happen? The inductor will completely get the full energy after some time. After some time, this guy will get full of energy. You understood?
Yes.
Yes.
If it is
Okay.
getting full of energy, it get full of energy. This guy become 10 joules, and this become 0 joules. Is it okay?
Yeah.
The
That's
capacitor
okay.
is completely discharging. I will draw the waveform. I will draw the waveform. What will be the equation for the current now? Previously, current was 0. Now, as the capacitor discharges, the current will increase, right? Current will increase, right? What will happen to the voltage across the capacitor? The capacitor was having full of voltage, but as it discharges,
decrease.
when the current become maximum, this guy become minimum. This is the voltage across the capacitor. So since the voltage across the capacitor becomes 0, the energy will be what? What will be the energy here? Energy becomes 0. And what will be the energy here? Here now, in our case, I have told you 10 joules. So energy, yes, 10 joules here. This is just an example, okay? I hope it is clear to you, right? Till now,
Yes.
it's clear.
Yes.
Now the capacitor has nothing. Capacitor has nothing. No electric field in the capacitor. Now, at this point of time, yes, it becomes short circuit. No electric field. But this guy is having full magnetic field. I hope it is clear to you. It is having full of magnetic field. Capacitor has no electric field. Okay. This current is inductor current, we can say, but it is also the capacitor current. Okay.
Doctor,
Sorry. Yeah.
you said here the capacitor will be short.
Capacitor will be short actually. Capacitor will be short means what?
Zero
It has
volt.
no energy. It is having no energy. That's the
What
meaning.
about the
Okay.
inductor?
Inductor is having full of energy and it is having maximum current. It is having maximum current now.
So will it
This
be
point is
open
clear
or
to you.
short? The inductor.
Inductor is having full of energy. It's a short circuit, but it is having full of energy also. A short circuit in an inductor and an open circuit or short circuit in a capacitor doesn't mean that it is not having energy. But if a capacitor is short circuit, it doesn't mean that it is having energy. If the capacitor is
No energy.
charged, if the voltage across the capacitor is 0, then it has no energy. That's the meaning. You understood?
Yes, yes. So now both of them are short circuit, right?
Now both of them are in short circuit. Don't think in that perspective. Short circuit, open circuit perspective. Don't think in that way. Okay, that will confuse you. Okay.
Okay, okay.
Now you think in terms of energy. Capacitor has no energy and inductor has full of energy. I hope it is clear to you, right?
Yes, that's
Now what is the problem?
Yes.
The current was flowing like this. The current through the inductor was flowing like this. IL of T was flowing like this.
Now it will
Now there is
flow.
now there is no energy in the capacitor to transfer. Nothing is there in the capacitor to transfer. But you know that inductor cannot change the direction of the current, right?
Yes.
yes.
So inductor will continue the current in the same direction. So what will happen if inductor continue the current in the same direction? Then if the inductor continue the current, inductor energy become reduced, right? Inductor will now start reducing the energy. It become 9, 8, 7, 6 like this. It will go down, right?
Right.
Because capacitor has no energy, so the energy has to come from inductor, and the inductor is not changing the current direction. So when the energy start decreasing, you know that energy for the inductor is LIL square. As energy decreases, what is the meaning? IL?
Current decreases.
Yes. So the current is now start decreasing. The current is start decreasing. I hope it is clear.
Yes.
When the current start decreasing, you can see that the current direction is same. The current direction is like this. So the capacitor is now charging like plus minus like this. Capacitor is charging plus minus like this. That
The
means
polarity
the
is
voltage now become, yes, the capacitor polarity, voltage of polarity become now 0. You can see I am drawing here. It will become 0. The capacitor polarity become, now when the inductor current becomes 0, when the current becomes 0, capacitor will be charged to maximum voltage. Do you agree with me?
Yes.
Yes, yes, right.
Yes.
Yes.
You know that when the capacitor charges to maximum, current becomes 0. That means now the capacitor charges to maximum. Maximum means negative, not positive voltage. Capacitor charges to negative voltage. Now what will happen? The energy here, energy become 10 joules, but
Minus.
negative voltage, right? Yes, negative voltage. And the inductor current become what? 0.
0.
0.
Yes.
But inductor cannot go quickly to positive. Inductor is coming from positive. You can see here this is positive, this is also positive, but inductor cannot direct. The current direction is like this. You can see the current direction same like this, right? The current direction is same like this, right?
Yes.
Yes.
Yes, the current direction was like this. The inductor current now goes to 0, and there is no energy. There is no energy in the inductor. Inductor energy is 0 joules, and the capacitor energy is now 10 joules. Now capacitor will, who will act like a source? Who will act like a source?
The capacitor.
Capacitor will act like a source, so the current will start flowing in the opposite direction, right? Current has to come from positive.
Yes.
That means now the current, inductor current is opposite. You can see, you can compare the old current and new current. Old current was flowing anti-clockwise, but new current is flowing clockwise, right?
So it will be negative.
Yes.
That means the potential becomes negative. That means not potential, the current through the capacitor is negative. So what will happen when the current reaches the maximum? The capacitor voltage reaches the minimum, right? So
Right.
now you got it. Now you got the idea, right? This is the idea. So sorry. Now you will get something very interesting here. Then after this we'll continue.
It's like a
And
circuit, right?
this yes, my drawing is not good, that's why. Okay, you will get perfect sinusoid. You will get perfect sinusoid, you can see.
Doctor, I have a question.
Sorry. Yes,
How the energy
it will be like
lose
this.
if it's transfer from capacitor to inductor? How the energy
And energy
will,
is not going to, how the energy will?
how the energy will decrease or lost?
Energy will not be lost in ideal sense. In ideal case, energy will not be lost. Okay?
Oh yes, doctor.
Yes. So what I
If
am
there
going to
are
say,
resistance- If there is resistance, it will be lost.
inshallah, that I will come to that later, inshallah. Okay? I will add the resistance. Then what will happen, inshallah, we will see. Okay?
Okay.
Now we have seen the inductor current is like this. Inductor current is perfect sinusoid like this. Okay, and the capacitor voltage across the capacitor like this, positive, actually it is 90 degree out of phase anyway. So when this becomes 0, this becomes maximum, and when this becomes minimum, it becomes 0, and after that it will be going like this. Am I correct? What I have drawn is correct or not? I think so. Is it okay? Yes. Same thing, right? I have to copy from the previous page, that's why. So this is what the working. So you can see here the inductor current will be oscillating like this, and the capacitor voltage will be oscillating, and the capacitor voltage will be oscillating just with a phase shift like this. Okay, so this is nothing but, if you measure the voltage across the capacitor, it will be looking like this, and if you measure the current in the circuit, it will be looking like this. Both are sinusoidal. Is it clear?
One is sinusoidal and another one is cosine wave, right?
Yes, cosine wave. So it is cosine, and this is sine. Okay. So it will be having a frequency. It can be proved that the frequency of this is 1 by root of L into C. Inshallah, we will come to this proof later. So it is having the frequency omega r. You can say the resonance frequency is 1 by square root of L into C. And this circuit, the circuit that we have seen now, is not as, the circuit is known as tank circuit. What's the name? Tank circuit. Because tank means, you know, a tank is used to store the water, right?
Yes.
Here there are two tanks. there are two tanks to store energy. One tank is inductor, another tank is actually capacitor, you can say. So there are two energy storing elements, and you can see that these guys will exchange the energy between them. They will exchange the energy between them. If you start this circuit, if you give some voltage to this circuit or just an impulse to this circuit, it will make the oscillation. It will make the oscillation. Is it possible practically?
No, doctor.
Practically, there is a problem because inductor is not a perfect inductor. If you take an inductor, you can see some small resistance also. This is a problem. A resistance across the inductor. Similarly, for the capacitor, you know, if you take a capacitor, then there will be a leakage, you can say, for the capacitor. Leaking means it's a resistance, small resistance, okay? RC or L, okay? So this will create a problem such that you can say there is a, instead of a resistance, a pure resistance and a pure capacitance, both are pure. This is also pure inductance. Then there is no issue, but you can say there is a resistance in the circuit which will create a problem. Let's say this resistance is R. So what will happen to the energy? What will happen to the current?
It will be decreased, the energy.
Yes, energy will be decreased. It will be exponentially decreased like this. So this is IL of T. The current will go down like this, and the voltage will exponentially decrease like this. And after some time, according to the time constant of this circuit, after some time, what will happen? You will get nothing from it. You understood?
Yes.
And who will eat the energy? Who will eat the energy? All the energy will be eaten by the resistor. Resistor will create the problem. You understood? It will eat all the energy. So I hope the tank circuit is very clear to you, right? So now we will come to our previous example. This one, you can see there is a resistor in the circuit. So you will get some oscillation. You can say you can get some oscillation, but after some time, the oscillation will be going
Zero.
to zero. Yes, this is the response. But we will prove it in very detail, inshallah. I think today it's not possible. I think so. Maybe in the next class we will prove it in very detail. Okay. So this is the inductor circuit. So you can see here, this is how it is behaving. So RLC circuit is behaving. But before ending, before closing today's lecture, inshallah, I will give you one more idea how your mobile phone is working, which is out of this context anyway. You have a RLC circuit. Suppose if you have a RL network like this, as we have told in the previous situation, you know that the current through the inductor will be sinusoidal, right? And the voltage across the capacitor will be cosinusoidal like this. Is it okay? I think you understood this, right?
Yes.
Time.
Yes.
Now what to do with this? Suppose you know in your mobile phone, how much is the frequency for 4G? It's in 4G. In 4G, what is the frequency?
Very high, I think.
For the carrier wave frequency.
I think it is
of the
by mega.
frequency is actually 2 gigahertz. You understood? 2 gigahertz.
Yes.
Suppose you are speaking to a suppose what will be your frequency of the message actually? If you are sending a message, or if you are chatting with your friend, or if you are just emailing to one of your friend, or if you are speaking to a friend, what will be the normal frequency range? It's small. the frequency will be very small. It's the order of kilohertz. You understood?
Okay.
So the message frequency is very small. And why you are using this much high frequency? Why you are using this much high frequency?
To keep the energy, I think.
Any idea, Ryan? I don't know what happened to him. Ryan is there?
Because
No
of
response.
voice.
No. Ryan is not there. I think something happened. Okay. So if you have a mobile phone, it's the frequency which is coming from it is 4 gigahertz. But if you are speaking to your friend, the frequency which is coming from your mouth is actually 3.1 kilohertz. Then why you are using this, not 4 giga, it's 2 gigahertz. Why you are using this much high frequency?
So it can reach to signal. The signal can reach to other person, I think, or to satellite.
No. You will mix this. Suppose this is M of T is the message signal, and this is your carrier signal. Then you will make a new signal which is S of T. In general example, I can say M of T multiplied with C of T. Okay. If you do like this, then this signal will be having high frequency near 2 gigahertz. Near 2 gigahertz, I will say. Maybe plus or minus 2 gigahertz, something like this. And why you are doing this task? Any idea?
Is it because the signal will reach faster?
No. The speed of the signals are actually speed of the light. Electromagnetic waves are all having speed of light. So if you have 3 kilohertz or
Doctor, do you mean a message like a text or a voice message?
it's a voice message, for example. Just consider a voice message. Simple case you consider a voice
Is
message.
it to make it more clear?
No.
Is it
There is
because
something.
the reach for wide people, for wide space?
No. You remember when I talk about the charges, antennas and all, do you remember something? How the antenna, suppose you have a wire, how the signal will be radiating from the wire. If you have a piece of wire, you give a voltage which is like this to a piece of wire, how the signal will be going? The electrons will be oscillating. You remember? To and fro. If you have a small piece of wire and you have a small frequency like this, if it is small frequency, then what will be the speed of the energy flow? You remember that?
Sure.
Yes.
Is it because cell phones
Yes.
doesn't transfer low frequency messages?
It can transfer, but there are some problems. I will tell you. I will make you more clear. Do you remember when a charge is, if you have a piece of wire, if a charge is moving like this, it's DC, then what will be the magnetic field or electric field? It is having a magnetic
Field.
Magnetic field. Now, if the charge is moving to and fro, acceleration, I think it has been covered in the first week, I think so. So if the charge is moving to and fro, then it will be having electric field. Yes, and magnetic field. That means electromagnetic field. Okay, electromagnetic field. So it will be having electromagnetic field. That's your wave. But if you take a small piece of wire and you give a voltage, plus suppose you are giving 10 volt here, immediately it will be 10 volt. You understood?
Yes.
It's because it's a small piece of wire and small frequency. So what will happen if your piece of wire is a small piece, and you are giving a small frequency varying very slowly, this is variation,
It
then
will take much
if this
time.
is 10 volt, it will be 10 volt, right?
Yes.
Yes.
That means all the voltage at each point, every point will be same voltage,
The same.
same wire. Yes.
Yes.
But what will happen if you take a large piece? Suppose this is a large piece, very large piece. Suppose this is a very large
It will
piece.
not be the same.
It will not be 10, right? Suppose this is a order of kilometers. If this is 10, this may be, suppose this is 10 here, this may be 9 here. So this guy may be at 9. When this guy goes to this 9, maybe 8 volt here, then this goes to 8 volt, then this may be at 10. You understood? Slow, delay will
Yes.
be there.
Yes. Yes.
So definitely there will be a delay. If there is a delay, that means that if you have a plus here, at some points there will be minus. You remember at different points, different voltages.
Yes.
Yes.
Traveling wave,
Yeah,
I have already told you, traveling waves, right? You will be having plus, minus, plus, minus, plus, minus. So you can see here, if you take a piece of wire, you have plus, plus, minus, minus, plus, plus, maybe different voltage. So you will be having plus, minus, like this. Okay? This is the distance,
Right.
you can say the distance. So it is not the function of time here, it's the distance actually. I am taking about the distance. So different part of the wire is having different voltages only if the wire is large, lengthy wire. Length of the wire may be of kilometers. And you are giving a small frequency of the order of maybe some 500 hertz. You understood?
Yes.
But so
Okay.
if you have so since you have different charges at different position, you have both electric field and the current is moving in this direction, so you have magnetic field. So what you will be having, the radiation will come out of the wire like this. It will come out of the wire. Yes, electromagnetic field. You will get electromagnetic field. You understood?
Yes.
Because of the electric, because of the charge, because of the change in the charge, you have electric field, and because of the current, you have the magnetic field. Because this is your voltage, so there will be a current. So because of the current, you have magnetic field, and because of the because of the electric field, changing the electric field at different position, you have magnetic field. So you have electromagnetic radiation. But the problem is, you need a very lengthy wire. Very lengthy wire. You understood?
Yes.
Yes.
Let us assume
Okay.
that the length of the wire is, length of the wire means h. So
We
to
can do this in
have,
cell phone.
we cannot do this in cell phone. I think you got the idea.
Yes. Yes.
You may need an antenna of length kilometers. Is it possible to carry in your pocket?
No.
Understood?
No.
I hope it is clear to you. You don't need further explanation, right? So what you can do, suppose you have a small piece of antenna. This may be your size of antenna in your mobile phone. Then the signal should change very fastly, right? If the signal is changing very
Increase the
fastly,
frequency.
then yes, so you will increase the frequency so that you can reduce the size of this. So if
Yes,
you
yes.
increase, you can actually reduce the size of the antenna. So if you increase the frequency, you can actually reduce the length of the antenna. You understood? There is a
Doctor.
formula actually. Yes. The length of the antenna is proportional to the wavelength lambda over 2. Lambda over 2 actually. There is a, you can say h is equal to some constant into lambda over 2. Let's say this just proportional to lambda over 2. Now we will see what will be the situation. Suppose you have 1 kilohertz, then frequency equal to 1 kilohertz. If frequency is equal to 1 kilohertz, you know that C equal to F into lambda. You know this formula from physics, right?
Yes.
Right.
Then what will
Yes.
be lambda?
C
3 into
over
10 power 8, yes, by F, 1 kilo, 10 power 3. This will become 3 into 10 power 5. That means 3, 1, 2, 3, 4, 5. This much meter. That means 300 kilometer.
100 kilo.
So your height of the antenna is proportional to 300 kilometer by 2. That means your height is approximately, you can say, 150 kilometer. You need an antenna of 150 kilometer to transmit a wave of 1 kilohertz. Is it possible practically?
No.
no.
This is the problem. Now we see when we convert it into, now we will see what will happen if frequency is equal to 2 gigahertz. Then what will be C? Equal to F lambda. So lambda is equal to 3 into 10 power 8 divided by 2 giga is 10 power 9. So 3 by 2 is 1.5 into 1.5 divided by 10. That means 0.15 meter.
150 something.
That means 15 centimeter, you can say 15 centimeter. Okay, so
Okay.
H is proportional to 15 centimeter
7.5.
divided by 2 is 7.5 centimeter. And I have just given you a rough number actually, 7.5. There is a constant because this is proportional. There will be a constant. So you may need a antenna of 1 centimeter or 2 centimeter. That is enough. You understood?
Yes, sir.
That's why we are using like this. So for generating high frequency, what I want to tell, for generating high frequency, we need a circuit which is known as tank circuit. So this is there in your mobile phone. But there is a problem with the tank circuit. Due to the practical components, the response will be decaying. You know this, right? If I give an impulse input, delta of
Yes.
t, it will respond, but the impulse will be decaying. So what you have to do to avoid this decay? You have to increase the strength of the signal, right?
Yes.
Right.
How you can increase the strength of the signal? By using an amplifier. By using an amplifier, you can maintain oscillation. You understood? So whenever your oscillation goes down, you will again amplify it. So what will happen? It will go like this. So you will get the sustained oscillation. You understood?
Yes.
By using
Yes.
amplifier. Yes. So by using, that means amplifier plus your tank. This we will call as another circuit which is known as oscillator. Inshallah, you will study oscillator in Dawah Electronia Isnain. Inshallah, this is the idea behind it. Okay. So you can see an inductor and a
Okay.
capacitor. Okay, inshallah, we will see the mathematical proof of this circuit, actually how to derive the equation for the current and the voltage, everything, inshallah, tomorrow. Okay. So I think this is enough for today.
Alaikum assalam.
I hope it's clear, right? Everything is clear.
Clear.